Welcome to another video. In this video, we are going to discuss important conclusions, equations, and some key points that you need to have on your fingertips to be able to answer exam questions from waves. Fill in the blank spaces with the appropriate formulas and units. Velocity को frequency and wavelength से relate करें. Velocity is the product of frequency and wavelength measured in meters per second. क्योंकि सारे velocities हैं तो measured in meters per second. Newton's speed of sound and then Laplace correction for the speed of sound. हमने पढ़ा है Newton considered the propagation of sound to be an isothermal process and he concluded कि जो speed of sound है it is the under root pressure over density. लेकिन इससे जो हमारे पास आंसर आ रहा था it was around 280 meters per second जबकि experimentally calculated speed of sound was 332 meters per second. Then Laplace made correction. He assumed that the process is not isothermal, it is adiabatic, and the temperature in the compression region is greater as compared to that in the rarefied region, वो comparatively cooler होता है. And he suggested that this equation should be revised as gamma P over rho. और इससे जो हमारे पास result आ रहा था, it was 333 meters per second, which was of course in close agreement with 332 meters per second, which was the experimentally calculated value. Speed of sound with respect to temperature. You must have derived the equation that speed of sound at a given temperature plus 0.61 for every 1 degree centigrade increase in temperature leads you to the speed of sound at any required temperature. Right? This equation here suggests that with every 1 degree centigrade increase in temperature, speed of sound increases by 0.61 meters per second. Let's just see a few questions from this topic and then we'll move forward towards the formation of the stationary waves. Velocity of sound waves increases, decreases or remains unaffected with the increase in temperature. यानी pressure increase होगा तो बताएं sound की speed पे क्या फर्क पड़ेगा temperature से और density से. To be able to answer these questions, दो equations हमें पता होनी चाहिए. First of all, speed of sound is corrected equation is this one and मुझे पता है PV equals nRT which is the well-known general gas equation which would be rewritten as P equals nRT over V. और जब मैं इसे velocity के लिए place कर दूं तो I can rewrite this Laplace equation as under root gamma nRT over V and this rho as it is. Now let's just see. Density के increase से sound की speed पे क्या फर्क पड़ता है? Velocity is inversely related to the under root of density, right? So it is obvious that with the increase in density, velocity of sound will decrease. How is the speed related with temperature? अगर आप इस equation को देखेंगे तो आप कहेंगे कि speed is independent of temperature, लेकिन अभी हमने पीछे भी एक equation पढ़ी और ये rearrangement भी आपको बताती है कि speed of sound depends on the temperature. It is directly related to the root of temperature. So of course with the increase in temperature, sound की speed increase करनी चाहिए उस medium में. Then how is it affected by the pressure? This equation suggests कि velocity is directly related to the pressure. तो अगर pressure increase होता है तो sound की speed बढ़ जानी चाहिए. But this is not the case here because every time we increase pressure, density also increases because particles are moving closer to each other, right? Volume available for them is decreasing. So pressure के increase से density भी equally increase होती है. They cancel out each other's effect and there is no resultant change in the speed of sound with the change in pressure, right? फिर अभी जो हमने conclusion derive किया density के केस में तो हमने कहा क्योंकि velocity is inversely related to the density तो फिर जो denser mediums होते हैं उसमें sound की speed जो है वो low होनी चाहिए. दिस मेक्स अस कंक्लूड कि फिर यकीनन गैसेस में साउंड की स्पीड सबसे ज्यादा होनी चाहिए बिकॉज उनकी डेंसिटी सबसे कम होती है। गैसेस के मुकाबले में लिक्विड्स में थोड़ी और कम स्पीड होनी चाहिए और सॉलिड्स में सबसे कम स्पीड होनी चाहिए साउंड की। But this table right here says otherwise. It says that the speed of sound in gaseous medium is smallest, liquid में उससे थोड़ी ज्यादा, and then solids में सबसे ज्यादा. Why is this so? General equation for the speed of sound in a medium is modulus of elasticity divided by the density. न्यूटन और लैपलास ने दोनों ने इसी बेसिक इक्वेशन से अपना कंक्लूजन डिराइव किया था, राइट? So this equation is always applicable when you are to calculate the speed of sound in a medium. सॉलिड्स में डेंसिटी ज्यादा होने की वजह से हम कहते हैं स्पीड कम होनी चाहिए, लेकिन हम ये बात इग्नोर कर रहे हैं कि सॉलिड्स में मॉडुलस ऑफ इलास्टिसिटी भी ज्यादा होता है और गैसेस के मुकाबले में अच्छा खासा ज्यादा होता है। So the effect of increasing modulus of elasticity is predominant in solids. This is the reason कि solids में density ज्यादा होने के बावजूद भी speed of sound is greatest. एंड लिक्विड्स का मॉडुलस ऑफ इलास्टिसिटी उससे कम होता है एंड गैसेस का सबसे कम होता है। दिस इज द रीजन कि गैसेस में डेंसिटी का इफेक्ट जो है वो प्रीडोमिनेंट होता है और सॉलिड्स में मॉडुलस ऑफ इलास्टिसिटी का इफेक्ट प्रीडोमिनेंट होता है। देन let's just see numerical question. It says if the speed of sound in medium A is 334 meters per second, then find the speed in medium B when the density of medium A is 1445 kilograms per cubic meter and the density of medium B is 1872 kilograms per cubic meter. Before calculating the value, what is your answer? What do you think? Speed of sound in medium B should be greater or smaller than that in medium A? Let's just relate it to the theory first. अभी हमने कहा speed is inversely related to the medium. तो अगर medium B की density greater है तो theory कहती है कि medium B में sound की speed should be smaller because it is inversely related to density. तो एक बात मुझे पता है theoretically VB should be less than VA. लिहाजा जो हमारा आंसर है it should be smaller than 334 meters per second. Let's just see. क्योंकि we know that speed and density are inversely related, so we can write VB equals under root of density of medium B in the denominator, and let's just compare it VA के साथ compare करें. This is the equation we will be using here, right? So VB equals rearrange कर दें VA, then we have under root density of medium A over density of medium B. Speed in medium A is 334. Density of medium A is 1445. Density of medium B is 1875. First divide them, then take the root and then multiply with 334. You will end up getting 293.45 meters per second, which of course is smaller than 334 meters per second. Then, in air, speed of sound at 7 degrees Celsius was found to be 335 meters per second. Speed at 7 degrees Celsius, 335 meters per second. What should be the speed of sound at 32 degrees Celsius? Speed at 32 degrees Celsius. Calculate. Again, recall the same equation. With every 1 degree centigrade increase in temperature, speed of sound increases by 0.61 meters per second. 7 पे velocity is given 335. आपको कैलकुलेट करनी है 32 पर. How much is the difference between 32 and 7? It is 25. यानी आप पता करना चाह रहे हैं अगर मैं टेम्परेचर 25 डिग्री सेंटीग्रेड इंक्रीज कर दूंगा तो फाइनल आंसर क्या होगा? See, this is the speed at 7 degree centigrade. This is the increase in speed due to 25 degree centigrade increase in temperature, and this together will give you the final speed at 32 degree centigrade. Just multiply these and then add it to 335. You will get 350.25 meters per second. q k speed increases with the increase in temperature, right? So of course it is greater than the one at 7 degrees centigrade, and kitni greater hogi? This relation right here. Then हमें पता है there are multiple ways in which more than one waves can encounter into a medium, right? Depending on उनकी direction of traveling क्या है, उनकी frequency कैसी है, superposition के different phenomena हैं, जिसमें से one is formation of a standing wave. Standing wave में भी we study three cases, जिसमें हम कहते हैं the medium is bound at both the ends, फिर हम कहते हैं the medium is open at one end and bound at the other, और फिर third case में हम कहते हैं the medium is open at both the ends. One thing we need to keep in mind is whenever the medium is bound at the end, इसका मतलब है medium particles cannot displace at the boundaries, right? That is the displacement of medium particle would be zero at the boundary. और अभी हम सबसे पहली स्लाइड में पढ़ के गए थे वो पॉइंट जिसमें मीडियम पार्टिकल की डिस्प्लेसमेंट जीरो होती है उसको हम नोड्स कहते हैं, राइट? सो वी हैव एस्टेब्लिश्ड दिस पॉइंट, जब भी मीडियम इज बाउंड एट द एंड तो फिर उस एंड पर नोड्स बनने चाहिए, एंड वाइस वर्सा, जब भी मीडियम इज ओपन एट द एंड तो फिर उस एंड पर एंटी नोड्स बनने चाहिए. Let's just recall the general equation. We know V equals F lambda, right? In these cases, they ask you to derive the equation for the harmonic in these cases, nth harmonic. And they ask you to derive the equation for the wavelength and then for the frequency of nth harmonic. Let's just see. All we need to do is relate the length with the wavelength, put in the values and get the final answer. First of all, if this is the length of your medium, right? Length L. What do you think? ये length किसके बराबर है? Half wavelength, right? So we'd write length equals lambda by 2. In other words, we could rewrite it as lambda equals 2 times the length. Second के लिए यही बात करें. This is the length of your medium, right? इसमें कितनी waves आ रही हैं आपके पास? 1 times lambda by 2, 2 times lambda by 2. In other words, a complete wave आ रही है. So you can write length equals lambda and lambda equals length. Then in this case, this is the length of your medium. 1 times lambda by 2, 2 times lambda by 2, 3 times lambda by 2. So you'll write length equals 3 times lambda by 2, or lambda equals 2L by 3. Then 1 times lambda by 2, 2 times lambda by 2, 3 times lambda by 2, 4 times lambda by 2. Length is 4 times lambda by 2. In other words, lambda is 2L over 4. Can you see the similarity? We have 2L, we have 2L, we have 2L. The only 2L missing is in this case. So let's just write 2 here, and इसको balance करने के लिए let's just write 2 in the denominator. Can we generalize this equation now? For this case, we have 2L over 1. For this case, we have 2L over 2. In this case, we have 2L over 3. And then we have 2L over 4. So we can generalize wavelength in terms of 2L over n, where this n can take all the integers. First 1, then 2, then 3, then 4, and then so on. How about the harmonics? How about the frequencies in this case? Once we know that V equals F lambda, this means F equals V over lambda. Let's just put in these lambdas in the corresponding loops, and then you will get to know the equation for the harmonic. See, if this is lambda 1, this is lambda 2, this is lambda 3, this is lambda 4, then F1 would be V over lambda 1. V over lambda 1 is 2L, right? F2 should be V over lambda 2. And we have already calculated this lambda 2, which is 2L over 2. Let's just shift this to here. Then F3 should be V over lambda 3. This lambda 3 is 2L over 3. 2L, this 3 right here. And then this F4 is V over lambda 4. This lambda 4 is 2L over 4. 2L, 4 here. Now, let's just see the resemblance. We have V over 2L here, V over 2L here, V over 2L, V over 2L. So we can generalize this formula for nth harmonic as V over 2L with this n here, and this n could take all possible integer values, that is 1, 2, 3, 4, and so on. Now, if they ask you to calculate the nth harmonic and they provide you with any value for n, you can directly just put in these values in these two equations and you can get to the final answer. This is what we call fundamental harmonic. This is the basic possible combination while keeping nodes at the boundaries, right? This is what we call first harmonic or fundamental mode. Then this is the next possible combination while keeping the nodes at the boundary. So this is what we call second harmonic or first overtone. Then this is the next possible combination, third harmonic or second overtone, fourth harmonic or third overtone. Now, if they ask you to calculate the fundamental frequency for eighth harmonic, right? So you'll just take eighth value of n, which is 1, 2, 3, 4, 5, 6, 7. Eighth would be 8. You'll just put in 8 here and you'll say F8 is 8 times V over 2L, right? And lambda 8 is 2L over 8. You'll just replace this n with the eighth value, integer value presented here. They might ask you to point the number of nodes or antinodes in the respective harmonic. For suppose they can ask you to label number of nodes in sixth harmonic. How do we get to sixth harmonic? Do we need to first of all plot the sixth harmonic और फिर उसमें count करके बताएं how many nodes or antinodes are there, or is there any general formula to get to the final answer as well? जनरलाइज करते हैं एक फॉर्मूला. फर्स्ट हार्मोनिक में वी हैड वन एंटीनोड, दो नोड्स थे, वन एंटीनोड्स, दो नोड्स. सेकेंड हार्मोनिक में वी हैव दो एंटीनोड्स and 1, 2, 3 nodes. Third harmonic में we have 3 antinodes, 1, 2, 3, and 1, 2, 3, 4 nodes. Fourth harmonic में we have 1, 2, 3, 4 antinodes, and then we have 5 nodes. Do you see the general trend? First harmonic 1 antinode, second में 2, third में 3, fourth में 4. इसका मतलब है अगर ये मुझसे पूछें सिक्स्थ हार्मोनिक में बताएं कितने नोड्स होंगे और कितने एंटी नोड्स होंगे, तो मैं कहूंगी सिक्स्थ हार्मोनिक में 6 एंटी नोड्स होंगे. नोड्स कितने होंगे? एंटी नोड प्लस 1. एक नोड था तो दो, एक एंटी नोड था तो दो नोड थे, दो एंटी नोड थे तो तीन नोड थे, राइट? सो वी से 6 plus 1, that is 7 nodes. This is how we generalize the formula for harmonic, wavelength, and number of nodes as well as antinodes, right? In past paper questions, they've been giving you the mode, figure बना के उन्होंने आपको दे दिया, इन डेट से बताइए कौन सा हार्मोनिक है, कौन सा ओवरटोन है, फंडामेंटल फ्रीक्वेंसी के लिए इक्वेशन बताएं इसकी, और इसके किसी फोर्थ या फिफ्थ ओवरटोन को ड्रॉ करें और उसकी फ्रीक्वेंसी बताएं, वेवलेंथ बताएं, नंबर ऑफ नोड्स बताएं एंड नंबर ऑफ एंटीनोड्स बताएं, right? So this is how you get to the final answer. Use the generalized equation, see which value of n corresponds to this node और फिर उस पे आप number of nodes और antinodes बता दें.